Hey guys, today we're going to talk about right triangle trigonometry applications. So we're going to apply all that stuff that we learned in Trig. This is actually much easier than a lot of the stuff we've already done. So just a refresher, here remember my reference angle, the side opposite is directly across from my angle. And then we've got the side adjacent is the leg that's next to the angle, and then the hypotenuse is always directly across from the 90-degree angle. And then we've got our 6 trig functions. Okay, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Remember SO, cot, TOA. And then the cosecant, the secant, and the cotangent are reciprocals of those things. Okay, so find the exact value of the 6 trig functions for angle theta. All right, so the first thing we need to do is make sure we know all the sides. So we'll use the Pythagorean theorem here, and we know that 5 squared plus 12 squared is going to equal the hypotenuse squared. And so 25 plus 144 is going to be the hypotenuse squared. So the hypotenuse squared is 169, and then we square root that, and the hypotenuse is 13. Okay, so this side's 13. Now once you have that, the rest is extremely simple. Sine theta is the opposite over the hypotenuse, so it's 5/13. The cosecant is the reciprocal of that, it's 13/5. The cosine is the adjacent over the hypotenuse, that's 12/13. The secant is the reciprocal of that, it's 13/12. The tangent is the opposite over the adjacent, 5/12, and the cotangent is the reciprocal of that, it's 12/5. So there's my 6 trig functions right there. Okay, this is what we're going to use a lot of this for, is solving a right triangle. Okay, so solving a right triangle means that you find all the angles and all the sides. Now in this case, we know 2 angles. We got the 90-degree angle, the 40-degree angle, and we know one side is 2. So we got to find the rest of that. So now, keep in mind that we always do this. When we have a triangle, we always label the angles where we'll label the angles A, or the sides A, B, and C, and then we label the angles alpha, beta, gamma. Okay? So alpha is across from A, beta is across from B, gamma is across from C. Always. Okay? So, here we're going to find alpha. That's the easiest thing to do because we know there's 180 degrees in every triangle. And so we know 90 of them are used up right there. So we'll get those out of the way. That leaves 90. And then there's 40 of them up there. So those are used up. That leaves 50 degrees. And they all have to be right here. So alpha is 50 degrees. Okay? Now I would like you to always, when you're solving a triangle, always put the information onto the triangle. Draw a picture that's big enough that you can read it all carefully and put it all in the triangle because it will help you, believe me, to solve these things. Okay, next we got to find B and C. Okay, so since we have all 3 angles, we can use whatever angles we want to solve this thing. But if I look at, if I use the 40-degree angle, I know that this is the side opposite and that's the side adjacent. So I can use the tangent. The tangent of 40 degrees is going to equal the opposite over the adjacent. And now I can just multiply both sides by 2, so B is going to be 2 times the tangent of 40 degrees. Now be sure that your calculator is set in degrees if your angles are in degrees, okay? If they're in radians, then you need to make sure it's set in radians. If you don't have the right one, you're going to get them wrong. Okay, so mine's already in degrees today, so it's 2 times tangent 40, close the parentheses, and I get B is 1.678. Okay? So I'm going to go over here and I'm going to label this 1.678. Now, some people might be tempted to use the Pythagorean theorem because you know two sides of a right triangle. Don't do that. Because this has error in it. Okay? This is not exactly 1.678. And if I have error and then I use it in another equation, now I have more error. Okay? So I'm going to use things that I know to be exactly true. I know all these angles are exactly those angles, and I know that side's exactly 2. So if I wanted to, I could use the sine or I could use the cosine to solve this pretty easily. So I'm going to go ahead and I'm going to use the sine. So the sine, that means that I need the opposite and the hypotenuse. Well, this is the opposite, and that's the hypotenuse. So the sine of 50 degrees is going to be the opposite, which is 2, over the hypotenuse, which is c. So I'm going to solve for c. c is in the denominator. I'm going to multiply it to the other side. So c times the sine of 50 is 2. And then I'm going to divide both sides by the sine of 50. So c is 2 divided by sine 50 degrees. So now I get out my calculator again, and I do 2 divided by sine 50, close the parentheses. Then I get c is approximately 2.611. Okay? So then I'm going to go and put that up here, 2.611. Now, I'm going to give you a little check that I would like you to do. This does not tell you your answers are right, but it will sometimes tell you if they're wrong. Okay? So there is a theorem that says that in a triangle, the smallest side is always across from the smallest angle. Okay? And the largest side is always across from the largest angle. So my smallest angle is 40 degrees. That means that this side, B, should be the smallest of the 3 sides. And it is. Okay? And then my biggest angle is the 90-degree angle. So the biggest side should be this side, the hypotenuse. And it's 2.611, and it is. So that's kind of a quick little check. I've found all 3 sides. I've found all 3 angles. This triangle's solved. Okay? Moving on. Solve this right triangle. Now the last one, I knew 2 angles and I had 1 side. This one I knew 2 sides and I have 1 angle. Okay, so the first thing I'm going to do is, I have 2 sides, I'm going to use the Pythagorean theorem to find b. Okay, so b squared plus 11 squared equals 61 squared. So b squared plus 121, let's see, 61 squared, I'm sure you all know, is 3,761, or 21, sorry. Okay, and then I subtract 121 from both sides, and I get b squared is 3,600, and I square root that, and I get b is 60. So now I know exactly all 3 sides. Now, since I know all 3 sides, I can use whatever trig functions I choose to find alpha and beta. Okay? So if I use alpha, I can use the tangent. The tangent of alpha is the opposite over the adjacent. Okay, now I need to undo this tangent here, so I'm going to use the arctangent. So alpha is the arctangent of 11 over 60. By arctangent both sides, the arctangent cancels out this tangent. All right, now remember, your arctangent on your calculator is the blue key right above your tangent key. So I'm going to go second tangent, that gives me the arctangent. I'm going to put in 11 divided by 60, close the parentheses and hit enter. And it tells me that alpha is approximately 10.39 degrees. Okay, you don't really, unless it tells you, you don't really need to go beyond hundredths of a degree. So this is 10.39 degrees right here. Now, normally I would tell you, don't use something this is not exactly, but it's rounded. I would normally tell you don't round, or don't use something that has error in it to find something else. But in our triangle, there must be exactly 180 degrees. So we're going to go ahead and just find beta by taking 180 and subtracting the 90 for that corner, so that leaves 90, and then subtracting 10.39, which leaves me with 79.61 degrees, and we're going to go ahead and write that right there. And now I've solved that triangle. I know all three angles, I know all three sides. So this is beta right here. And here's my B. Okay. Notice in the triangle that the tangent of alpha and the tangent of beta are inverses of each other. So if I look here, the tangent of alpha is the side opposite, which is A, over the side adjacent, which is B. So here's the tangent of alpha. If I look at the tangent of beta, that would be B, the opposite, over the adjacent, which is A. So, and that's going to be true for any right triangle. So, theorem for any right triangle, the tangent of alpha is always the reciprocal of the tangent of beta. Now, it's also true that the sine of alpha is going to equal the cosine of beta. So let's take a look at that. The sine of alpha would be the opposite A over the hypotenuse C, so we get A over C here. But the cosine of beta would be its adjacent, which is A, over the hypotenuse, which is C. So those are the same thing. For any right triangle, the sine of alpha is the cosine of beta, and the cosine of alpha is going to be the sine of beta. Okay, that's going to help us with problems like this. So I've got the tangent of 12 degrees minus the cotangent of 78. So if I look at that, these two angles add up to 90. All right? If they don't add up to 90, I really can't do this. But if I have a right triangle, and this is 12 degrees, and this is 78 degrees, okay, and I label my sides A, B, and C, then the tangent of 12 is the opposite over the adjacent. That's A over B. And the cotangent of 78 is the adjacent over the opposite, so that is also A over B. So if I take A over B and I subtract A over B, I get 0. Okay, find the exact value of cosine of 63 minus the sine of 27. So with this, again, 27 plus 63 is 90. So I've got a 90-degree angle here. That means this is going to be 27, and this is going to be 63. Okay, so if I label my sides, A, B, and C again, then the cosine of 63 is going to be adjacent, which is A, over the hypotenuse, which is C. And the sine of 27 is going to be the opposite, which is A, over the hypotenuse, which is C. So again, this is 0. Okay, find the exact value of the cosine of 46 divided by the sine of 44. So again, these two angles here add up to 90. So they're both in the same right triangle. We'll say this is 44 degrees, this is 46 degrees, and then this is 90. Okay, we'll label our sides A, B, and C. Okay, now if I look at what this is, the cosine of 46 is going to be A over C. And the sine of 44 is going to be the opposite over the hypotenuse, which is A over C. And A over C divided by A over C is just 1. All right, so here we have a story problem. Okay, a surveyor can measure the width of a river by setting up a transit at point C on one side of the river and taking a sighting of a point A on the other side. So what's a transit? A transit, you see these guys on the side of the road, they got the orange flak jackets on, you know, the bright colors, and they're looking through these things that are on a tripod. That thing on top of the tripod is called a transit. And what it does, it measures angles this way, and it measures angles this way. Okay? And so what he does is he sets up right here at point C, and he locates an object across the river here. Let's say it's a rock or something, or it could be a bush or a tree or whatever. Okay? And so he wants to calculate the distance across the river. Now, he doesn't want to get wet, right? So he doesn't have to get wet because he's going to use trig. So he's going to set this up, his transit up here, he's going to sight this in across here. And then he's going to measure a 90-degree angle with his transit, and he's going to measure 200 meters down this side of the river. Okay? So he's got these two sides of the triangle, and we're trying to figure out that side right there. Okay, once he goes 200 meters, he sets his transit up here at point B, sights in the original point C, and then he measures a 20-degree angle, or he measures the angle to this object right here, which he finds to be 20 degrees. So he knows this is a 20-degree angle right there. And now he's got enough information that he can calculate the distance across the river. So the distance across the river, this is the side opposite right here. This is the side adjacent. So he can use the tangent. The tangent of 20 degrees is the opposite over the adjacent. Now that's simple to solve. Multiply both sides by 200, so x is going to be 200 times the tangent of 20 degrees. And then 200 times tangent of 20 on the calculator comes out to be approximately 72.79 meters. So he got the distance across the river, never got wet. It's like math magic. Okay, he measured something without measuring it. All right, he never went across here, but he knows the distance. All right, so here we have a trail. A straight trail leads from an alpine hotel. It's a nice alpine hotel right here. And it's at elevation 8,000 feet. And the mountain peak is 11,100 feet right here. And the length of the trail is 14,100 feet. That's this distance right here. Find the inclination of the trail. So find how steep is that trail right there. Find angle B. We're going to find this right here, or beta, angle beta right here. Okay. So here's what most people do is they go, okay, I know the opposite, I know the hypotenuse, that's going to be the sine. So the sine of beta is going to be the opposite over the hypotenuse. Now the hypotenuse, 14,100. Now here's what a lot of people do, is they'll put in 11,100 right here, and then they calculate this thing and they get it wrong. Because remember, you're not going from sea level to the peak. You're already at 8,000 feet when you leave. So this right here, I need to take the 8,100 or 11,100 and subtract the 8,000. This side is 3,100 feet. That goes here. Okay, now I can solve this thing because I can arc sine both sides of this thing. So beta is the arc sine of 3,100 divided by 14,100. Okay, so arc sine, second sine, 3,100 divided by 14,100, close my parentheses. Beta comes out to be 12.7 degrees. Now, it doesn't seem like a very big an angle, but let me tell you, that's a steeper incline than you think it is. Okay, so just some things that you make sure you understand, the terms. So if I'm looking up at an object, okay, the angle formed by the horizontal and the object is called the angle of elevation. And if I'm looking down at something, the angle from the horizontal to the object below is called the angle of depression. Okay, find the height of the Statue of Ceres atop the Chicago Board of Trade building given the following data. Two observations are taken from 400 feet from the center of the building. The angle of elevation to the base of the statue is 55.1 degrees. The angle of elevation to the top of the statue is 56.5 degrees. Okay, so with just that, can I figure out the height of that? And the answer to this is yes, because I've formed a couple of right triangles right here. And keep in mind there's a second one that goes here. Now it's important it's said to the center of the building because the statue is in the center of the building here. Okay, so I need to do this problem twice. I need to figure out x, which is going to be the blue one, and I need to figure out y, which is going to be the red one. Okay, so this is the side opposite. This is the adjacent. I'm going to use the tangent. So the tangent of 55.1 degrees is going to equal the opposite, which is x, over the adjacent, which is 400. And so x is going to be 400 times the tangent of 55.1 degrees. So 400 tangent 55.1 is going to be 573.39 feet. Okay, so that's the side of the blue triangle. Now I also need to do the red one. So this one, the tangent of 56.5 degrees is going to equal y over 400. Basically the same thing I did here. Y is going to be 400 times the tangent of 56.5 degrees. And I get y is 604.33 feet. That's this over here. Now I can calculate the height of the statue because the height of the statue is the difference between this and the blue one. Okay, so 604.33 minus 573.39. What is that? Comes out to be 30.94 feet. And that's my answer. Okay, meteorologists find the height of a cloud using an instrument called a ceilometer. A ceilometer consists of a light projector that projects a vertical light beam up from a cloud base and a light detector that scans the cloud to detect the light beam. A ceilometer with a base of 300 feet is deployed to find the height of the cloud cover. If the angle of elevation of the light detector is 75 degrees, what is the height of the cloud cover? Okay, so here's what happens, is I take my really bright light and I put it right here and I shine it straight up to the cloud. Okay? And then this distance here is measured to be 300 feet. So this is where my light detector is, and it focuses in on where that light is on the cloud. And it measures this angle right here. So this is now 75 degrees, that green angle. Okay, I know this side, which is the side adjacent, and I know this, and I want that side, which is the hypotenuse. So I'm going to use the tangent. The tangent of 75 degrees is the opposite over the adjacent. So I would multiply both sides by 300. And I get 300 times the tangent of 75, and that comes out to be 1,119.62 feet. All right, so here's your assignment for the day. Give that a try, and I'll see you in class next time.